Right. Question 7. By using the substitution u equals sec x or otherwise, find an expression for the definite integral between pi over 3 and 0 of sec to the power of nx multiplied by tan x dx in terms of n, where n is a non-zero real number. Right. Okay. Let's charge on. So let's highlight this idea of using this u substitution. Okay, and we're going to have to rewrite our definite integral here in terms of u, and then integrate it with respect to u as well. All right, so let's go over to our formula booklet and let's get a bit of info that we're going to need. So we're going to need the going down here, the definite, the derivative of sec x. So we've got that here. Let's bring this over. This is going to be helpful. And we're also going to need to know the idea of what sec x is, and it's 1 over cos x, which is also in your formula booklet. If we go up to here, where are we? Did I go past? No. Section 3, right? Yeah, here we go. So reciprocal trigonometric identities. So this one here. Okay, so let's bring this over. All right, yeah, that'll do. Let's maybe make that bigger. Okay, so first things first, we're going to need to make our u substitution. Okay, but then we're going to need to integrate our integral with respect to u. So we're going to need to have du on the end. Okay, so if we go through and sort of find, well, if u is equal to sec x here, that means therefore du dx is going to equal what we have, just over here. All right, so that's sec x tan x. All right, so the best thing we can do, or the ideal situation, is we can get an expression for du that looks something like this, tan x dx. And then we can sort of just replace tan x dx with du, or the little manipulation that we may do to du, and then we can sort of have a integral with respect to u. Okay, so if we rearrange this this thing here, we could say we've got du is over sec x. All right, so dividing both sides by sec x and multiplying by dx. In fact, we'll show that. This is going to equal tan x dx. All right, which is identical to the end. We go here to the end of our integral in terms of x. All right, now let's say what we've done here. So here, going down, what we've done is we've multiplied by dx. How much we can say multiplied by dx over sec x. That's effectively what we've done here to rearrange it to this. And I'm also going to actually make another adaptation here. And what we can recognize is that du over sec x would just be the same as du over u. Or alternatively, what we could say, we could say that du over u. Or alternatively, you could call it 1 over u multiplied by du, which is effectively what we're going to end up using for our definite integral. Okay, so now we have an expression for du, which is then divided by u, and that equals tan x dx. So we can substitute in, we can sort of swap in this du over u for tan x dx, and then make our u substitution, right? That's going to look a little bit like this. All right, so let's go for it. We're going to go, not got my pen. All right, so it's going to be u to the power of n divided by u and then du. All right, we're going to have to say that in this here, we've got x is equal to pi over 3 up the top here, and then x is equal to 0, because we're also going to have to make we're going to have to change our x values to be in terms of u, right? And that's what we're going to do in the next step. Let's just bring that down to there. All right, cool. And also I brought this u to go under the un. All right, if it was under the du, you bring it over. Okay, same thing. Okay, so now we're going to think if x is equal to pi over 3, then what would u equal? Okay, so if we come over here and we have a look, we can say we've got x is equal to pi over 3. Therefore, u is equal to sec pi over 3. All right, which is just going to equal the reciprocal of cos pi over 3. Right, so 1 over cos pi over 3. And if you remember your exact value triangles, or here's the right-angled exact value triangle for pi over 6 radians and pi over 3 radians. It's essentially an equilateral triangle with side length of 2, and then you cut it in half, as you can kind of see there, and then that gives us all our values for pi over 6 radians, pi over 3 radians, and so on. Okay, so that means if we have sec pi over 3, and we know that cos pi over 3 is going to be adjacent over hypotenuse, which is a half. So it's effectively going to be the inverse, or sorry, the reciprocal of a half, which is going to be 2. Okay, because cos pi over 3 would be a half, so then sec pi over 3 would be 2. And now if we do the next step for that here, we can go x is equal to 0. That means u is equal to sec of 0. And the best way to answer this would be to just sort of go back to your the cos graph, right? We know at 0, it's at 1, right? So that means that equals 1, right? A neat, nice, easy way you can do that. And I recommend sort of being able to do a quick sketch of your graph. That's definitely far from perfect, but it doesn't need to be perfect. So that's the cos graph there. And the sine graph, starts at 0 and goes like that. Okay, a little way you can remember that is that C comes before S in the alphabet. So the cos graph starts at 1 and the sine graph starts at 0. That's a little way I've gone to remember it, but yeah, you can just memorize it, I suppose. Yeah, there we go. Let's get rid of the sine graph because we don't really need that. Okay, sweet. So then now moving on, we can sort of make our full u substitution and substitute them in for the x values. So that's going to look a little bit like this. What I could even do is just copy this down and we'll get rid of these. And we'll say that the u values are from 2 to 1. And equally what we could do, we can change this expression un over u. We can change it to u to the power of n minus 1. All right, because this rule is from the indice law. That is, if you have, let's say, a to the power of m over a to the power of n, this is equal to a to the power of m minus n. All right, so little indice law there to memorize. Okay, and it'll help us out. All right, so now we're just going to run through and use our normal integration rules with respect to integrating with respect to u. And so that's going to look a little bit like this. We're going to get, well, adding 1 to un minus 1 will be just n. All right, and then we're going to have to divide by the new power that we have, which is n minus 1 plus 1, which is just going to be n. And now we're integrating this between the limits of 2 and 1. And so then this is going to equal 2 to the power of n over n, subtract 1 to the power of n over n. Now, 1 to the power of anything is just 1, all right? So that's just going to be, oh, whoops, sorry. Line loads up a bit better. All right, so 1 to the power of anything is going to be 1. So we can just replace that, and we have a common denominator. So then our final answer is going to be 2 to the power of n, subtract 1 all over n. And that is the answer to question 7.